So, last practice problem in the notes right here. This question about hydrocarbons, hexane and hexene 1 or 1-hexene. The enthalpy of formation of hexane, C6H14, is negative 199 kilojoules, and the enthalpy of formation of hex-1ene, C6H12, is negative 73 kilojoules. Draw a Hess loss diagram in order to calculate delta H for the conversion of the hex-1ene to hexane by the addition of hydrogen. Then B, calculate another value for the reaction and using the average bond energy terms. Which of your answers, A or B, will be more accurate and why? It'd be a good idea to try to do this one before you watch the video, but we should go over it anyways. So first thing we're going to do is set up our equations. So our goal equation is this one down here. We want to make the hexane from the hex-1ene and hydrogen. So that's our goal. They gave us the heat of formation for hexane and hex-1ene. So we're going to put those in. We balance them out. When we go to add these, we'll see that the second one needs flipped, which means the sign on this one gets flipped, and we add them together to get negative 126 kilojoules per mole. And then the second part is we have to use bond energies. So bond energies are the one thing where you don't do products minus reactants. Ooh, can I show it all? Get rid of that completely. So we go ahead and we have our chemical equation we're interested in. We're going to figure out what bonds we need to break. We need to break that double bond and the hydrogen bond. We're going to make a carbon-carbon single bond into hydrogen-carbon bonds. We put those into our equations. We look them up from our table. We got 620 kilojoules per mole for the carbon-carbon double bond, 436 for the hydrogen-hydrogen bond. The carbon single bond is 376, and then 2 times the hydrogen carbon bond, which is 414. Plug that in a calculator, you get negative 146 kilojoules per mole. So as was said multiple times, bond energies are an approximation, so they're the less accurate ones. So the first one is the one you want to go with.